here is an impulse momentum problem about a lacrosse ball that bounces off a concrete wall. This gives people a little bit of difficulty because bouncing often gives people trouble, and the shape of the curve. So let's read this and see how we should proceed. There's a 78-gram Wilson lacrosse ball. It's tossed with a speed of 21 meters per second towards a rigid concrete wall. It hits the wall and bounces back with the same speed. The graph shows the force of the wall on the ball during the collision. All right. What do we want to find here? What we want to find is, what is F max? Find F max. Well, J is the change in momentum. Impulse. Impulse is the area of an FT graph. So that's going to equal the change momentum, which is the mass times the velocity final. That's momentum final, minus the mass times the velocity initial. That is momentum initial, since momentum is mass times velocity. Well, this area here, it's a trapezoid. There's a couple ways you could do it. It's a pretty symmetrical trapezoid, but we're going to stick with just the equation for a trapezoid, which is 1/2 base 1 plus base 2 times height. So our height is here. That's the height. That's F max. Base 1, we'll call the bottom, that's 4 milliseconds. Got to be careful of units. And the top goes from here to here. So how many milliseconds is that? Well, this is 2, and so these are divided into thirds. 2 divided by 3, so that's 2/3. That's 4/3. And then this would be another 2 2/3. So from here to here, that's a 4/3 is this base, 4/3. So this is going to become, there's our bases 1 and 2. We'll come back to that. What's this side of the equation? Well, it's got a 78-gram mass. We want this all to be in base units, so we need kilograms. So that's going to be a 0.078 is the mass. The velocity final is 21, but which way? A before and after picture would have been nice. So it starts out this way with a velocity initial towards some wall, and then afterwards it's moving that way with a velocity final. So they're opposites. So if we take the initial to be towards the right, then the final would be towards the left. So this final is a negative 21 minus the initial, which we've got again 0.078 kilograms and a 21 meters per second. So now let's plug in this side. 1/2 base 1 is 4 milliseconds, remember, milliseconds, plus base 2 is 4/3 milliseconds, times the height, which is F max that we're trying to find. Doing some calculations on the top there. We've got 0.078 times 1. We're going to get a negative 1.638 minus 1.638, so it's double that mass times its velocity. So that's going to be a negative 3.276 Newton seconds for now. And this side, we've got 4 plus 4/3, so we got 12/3 and 4/3, so 16/3. So 5 1/3, 1/2, 5.33 times F max. Now that's in milliseconds. This is in newtons times seconds. We got to reconcile that. So we're going to convert this milliseconds to seconds by dividing that by 1,000. That's 0.0053. So we've got a half of 0.00533 F max. And that's going to equal our negative 3.276. Now we're all in seconds and seconds, so that's going to work out. We just multiply by 2 and divide by that. Enter times 2 divided by, and we get that F max is going to equal 1,228.5. Looks like we got 2 sig figs, so 1,200 newtons is F max. Okay, so tricky part there is the area of the trapezoid. There's the equation. It's bouncing, so it was going to the right at the beginning and then to the left at the end. Make sure we take care of that direction. Then it's a bunch of algebra. Now an easier way to do this trapezoid is you could recognize that this triangle really just fits right in there, and we get a rectangle with a base of 2 2/3 and a height of F max. And that's what you would get, in fact, when you do half of base 1 plus base 2, is you get that 2 2/3. Okay, good luck. Hope that helped.